Yeah, so if this block is going y distance downward, then the string, the slacked amount of string, suppose there's y unit of string slacked here, then it will go y distance down. So for this to go y distance down, it just requires y unit of a string to be loose. So if this goes x distance, it loosens 3x unit of string. And if it goes y distance, it tightens y unit of string. String will remain tight all the time. That means 3x must be equal to y. So dy by dt should be equal to 3 times dx by dt. So the velocity, this is given as 1 meter per second. So the velocity of this mass should be equal to 3 meter per second. Right? Okay. This is a situation, this two block A and B, they are making an angle of θ1 and θ2. Both are moving horizontally with velocity VA and VB. You have to find the relation between the velocity VA and VB. Not a new kind of job, it's just the repetition of the same thing, but it's a new question and it requires a new kind of energy. So let's put some new energy into it and let's solve this. So the approach here would be pretty much the same as we did for the previous questions. Let this distance be LA and let this distance be LB. Now this distance, let's call this as B, and this is going to remain constant. Fine. So the length of the string would be root over LA square plus B square. This is this length plus root over LB square plus B square. This is a constant. This is the length of the string. So we have written successfully the constraint relation. Now we got to do some differentiation. We'll do that. Differentiation of this is 1 upon 2 root over LA square plus B square into 2LA into dLA by dt. This is the differentiation. Similarly, on the other side, we will have find the differentiation of C will be 0. When this goes on the other side, there's a negative sign that appears. So this is the relation we have. And let's see what we can do now. This 2 will be cancelled. And dLA by dt is the velocity of A. And minus dLB by dt, or dLA by dt is the velocity of A. But if you look at the sign, dLA is the change in length of this distance LA. Like dx is the change in the distance x, dLA is the change in the length of LA, and the sign, if you see d differential of anything is always the final value minus initial value. The final value of this is going to be less than the initial value because block A is going to come nearer and the distance is going to decrease. So the sign of dLA is negative. Understood? So dLA is a negative quantity and dt is a positive quantity. Dt is a change in time. The final time would be more than the initial time. So the change is positive. This dLA is negative. So if we are taking the velocity, the right hand side as the positive direction, then this is a negative number. If you add a minus here, then it becomes a positive number. So VA is actually equal to minus dLA by dt. So this dLA by dt is minus VA. So we can write this as LA minus VA upon root over LA square plus B square is equal to, the minus sign will be here. In this case, the sign of dLB is positive because this LB length is going to increase. So final minus initial will be positive. So dLB by dt itself is VB. Fine. Now from this triangle we can see very easily that LA is this is the base and this is the hypotenuse. So this is actually base upon hypotenuse. This is actually cos theta 1. So this is minus LA cos theta 1 is equal to minus minus VA cos theta 1 is equal to minus VB cos theta 2. Fine. So the relationship between VA and VB is this. VA cos theta 1 is equal to VB cos theta 2. This is the required relation. Fine. So basically it's the same thing as you must have observed till now. That you write a proper constraint relationship, you do the differentiation and things comes out very easily from there.